Okay, welcome to Psych 200 Research Methods. Today we're going to be talking about Chapter 7. We're going to be talking about non-experimental and quasi-experimental designs. Okay, there's a lot of different types. So let's get to it. What are non-experimental and quasi-experimental designs? So here's the thing. We talked about experiments. Okay, and it turns out that there's a whole bunch of other studies that are kind of like experiments, but not really experiments, or there are studies that do some similar things, but they're not really experiments. This is what we mean by non-experimental, quasi-experimental designs. So here's the thing. It's often difficult to satisfy the demands of the experimental research strategy. The demands, right, that you have an independent variable, you manipulate things, and you compare groups. All the different things that you do for an experiment, it's often hard to do that for some studies. Like some examples would be an applied research in natural settings like education, clinical research with real clients, stuff like that. Let me give you an example. What if you want to study, the effect of spanking on, let's say, on self-esteem? You can't do an experiment like that. You can't do an experiment where you manipulate that. You can't have, people come into the study or children come into the study, right? Let's say with their parents, and in one group, the parents spank their kids, another group, they don't spank their kids. That would be unlawful, okay? You'd get in trouble for that, okay? You can't do that. You can't manipulate spanking, okay? But here's the thing. Spanking happens on its own already in the real world. So you can still compare those groups, but you can't manipulate it in the laboratory. You can't really do an experiment, a true experiment, I should say. There's other examples. There are people who have experienced neglect, or people who have gone through all sorts of things, that you cannot manipulate because it's just unethical. But you can find these people, and you can see if there are differences between them. That really wouldn't be an experiment, but it does some things that are similar to experiment. So you can use similar research strategies that fail to satisfy one or more of the requirements of experiments. You can do something similar. You can still at least compare groups, even though you can't manipulate, you can't create those groups. You can't always create them. You can't always, manipulate the independent variable, right? But you can use some of these strategies that we learned about when we talked about experiments. These, by the way, these studies that I'm talking about, they will not establish an unambiguous cause and effect relationship. What that means is that was there really cause and effect in this type of study? It's hard to say, right? It's not clear. That's what unambiguous means, right? That it's not really clear whether, A really led to B, because you didn't really do all the things you needed to do a proper experiment. Let's talk a little bit more about that so you understand what I'm talking about. So first, let's talk about these. Okay, so the non-experimental research strategy, for instance, makes little to no attempt to limit confounding variables and threats to internal validity. The non-experimental research strategy doesn't try to limit any confounds, right, or threats to internal validity, threats to cause and effect. And I'll give you some examples in a moment. Quasi-experimental designs are a little bit different. They attempt to limit some of the threats to internal validity, right? Some of the threats to cause and effect, and may approach the rigor of experiments. So quasi-experimental designs are a little bit more like experiments. They try to do some things are done for these designs to make them a little bit more like experiments, but they're not really true experiments. And with non-experimental designs, you really don't try to do much at all, right? To minimize the problems of a real experiment, okay? To minimize the threats to internal validity. And we'll talk about these, okay? Let's talk about the structure of non-experimental and quasi-experimental designs. So both non-experimental designs and quasi-experimental designs produce groups of scores to be compared for significant differences. So you're still going to compare groups, okay? At the minimum, you need to do that. To have a non-experimental design or a quasi-experimental design, you need to be able to compare groups, okay? So you're going to have groups. But the groups are not created by manipulating an independent variable. You don't create these groups. It's not like you're going to say, okay, this group gets spanked and this group does not, right? You can't do that with spanking. You can't do that with abuse, physical abuse or sexual abuse. You can't do that. It's unethical, right? You don't create the groups. The groups already exist. The groups can be defined in terms of participant characteristics. You can compare males and females. They already exist. You didn't create these groups. Or you can have, children that experience spanking and those that did not. They already exist. You can compare them. Or you can compare people who have, before treatment and after treatment. So basically, you're still going to have groups. You're still going to compare them, but you don't necessarily create these groups. You don't always do some manipulation to create these groups. That's the difference. If it's a between subjects design, these are also called non-equivalent group designs. Okay. If it's within subject designs, they're also called pre and post designs. We're going to talk about both. Okay. When you have between subjects design, it's called non-equivalent groups. And when it's within subject design, it's called pre and post designs. Let me warn you here. Okay. There's going to be a lot of terminology, a lot of different types of designs with a lot of different names. Try not to let that intimidate you. It's not hard to understand. It's just a bunch of terminology and you need to know some of it. Okay. Let's keep going. Here's an example of a study that is not a real experiment. Okay, actually, no. This is one that is a real experiment. Okay, the structure of an experiment. I told you guys about this already. We just finished talking about this. So you can have participants, let's say, watch a group of participants watches violent TV, and another group of participants watches non-violent TV. Okay, and then you compare, and well, you measure the level of aggression, and that's the level of aggression for the different participants under TV violence. You have one person who scored a 17, another one 19, 16. That's the level of aggression. And then those that were in the no TV violence group, you have their scores there. One got 12, another one got 10, right? That kind of stuff. And you compare the scores. You want to see if there's any difference between the groups. You would compare the averages for those two groups. That's what you do with a true experiment. Here's an example of something else, okay? Of something that is not a true experiment, okay? Something might be non-experimental or a quasi-experimental design. So the first example there, college graduates and those that have no college, those that got no college, right? You can compare these different groups. You can compare the verbal test scores of those that are college graduates. So they get some verbal tests, right? And, first one there under college graduate got 17, other one got 19, and you see the scores there. And then you give the same verbal test to those that have not had any college, right? They don't have a college degree. They haven't been to college. And you see their scores there. One person got 12, another one got 10, 14, etc. You can tell the scores are a bit lower. You compare the differences between those that went to college and those that did not. You can compare their verbal test scores. Okay, and that right there is an example of, a non-experimental design, right? It's not an experiment, but you're still comparing groups. The second one there, you have right there groups. So you check the depression, right? You give some depression measure to participants. You give them this depression measure before therapy. And those are their scores there, 17, 19, 16. Each score represents a different person. And then they go through therapy for their depression. And then they get the same test of depression or same measure of depression afterward. And you can see the scores afterward, 12, 10, etc. You can see that they're probably a little bit different. And then you compare the difference before of the scores before therapy and after therapy. That would be more of a quasi-experimental design. Okay, not a true experiment. Okay, but it's a little bit closer to an experiment than than the first one where you just compare groups. Those are just some examples, right, of designs that basically where they're not really true experiments, but they are similar in the sense that you're still comparing groups. And it depends on what you do. That determines if you have a non-experimental design or a quasi-experimental design. So an example, here's another example of a non-equivalent group design. And remember, the non-equivalent group design is when you have between subjects designs that are not true experiments. So you have different participants in the different groups, but it's not a real experiment, okay? You're just gonna compare groups. So an example of a non-equivalent group design would be a teen pregnancy program, where you compare pregnancy rates in a high school that has the teen pregnancy program, and you compare the rates of pregnancy in a high school where the program does not exist. So let's say you have this teen pregnancy program. You have a high school where they educate the students about the problem of teen pregnancy and how bad it is, and stuff like that, to get pregnant when you're a teenager, right? And so they tell them about that stuff. And they also provide information about contraception and maybe even pass out condoms and things like that. So students are more likely to protect themselves, let's say, if they should have sex. And then you have another school where they doesn't have the program and they don't tell their students about the problem of teen pregnancy. They don't tell them about contraception. They don't hand out condoms and things like that. And you compare what's the rate of teen pregnancy in one school versus another. And you'll probably find that in the school where they don't educate students about teen pregnancy and provide information about contraception and stuff, you probably find that a greater percentage of teenage girls there get pregnant than in the other school. That's probably what you're going to find. Notice this is not really an experiment, but you're comparing groups, okay? It's a non-equivalent group design. You're comparing groups, but it's not a true experiment. You have no control, right? There are problems. You have no control over who's assigned to which group. You have no control over whether the people, go to the school with the teen pregnancy program or the one without it. You don't get to decide that, okay? It's not a true experiment. You don't get to pick who goes in the treatment group or who goes in the control group, right? You don't have control over that. You cannot use random assignment. You cannot minimize the between group differences. You have no control over this stuff. It's not a real experiment. There's lots of problems, but you can still compare the groups. And here are some problems to this, to these non-equivalent group designs. You can have assignment bias. Okay, assignment bias basically. That's when the assignment procedure produces groups with different participant characteristics. Now, you didn't get to assign the participants when you compare a school with a teen pregnancy program and one without. You don't get to assign them. So yeah, there's going to be problems with who's in what group. You still have assignment bias, even though you didn't assign them. You have bias because there's two schools where you have this where you're evaluating this teen pregnancy program, right? One where it exists, one where it doesn't exist. They can differ in IQ. Maybe one is a better school than the other as far as the students go. Maybe it's just the students in one school just are smarter than the schools in the other school on average, right? SES stands for socioeconomic status. It could be that in one school, the students are poorer than in another school. You have schools in, really nice, expensive neighborhoods, right? And you have schools in other neighborhoods that are not so nice, that are really poor. And the students can be very different in these different neighborhoods, okay? Different racial mixture. As you guys know, the poor neighborhoods tend to have more minority students, more Latinos, more Black people, right? And the richer neighborhoods tend to have more white people. All these differences, right? The schools can be different in different ways, okay? That's why it's called the non-equivalent group design. Because the schools or the groups are gonna differ on their own. You don't have control over that. You can't make it so they don't differ that much. You can't use any of the techniques to minimize these differences. You don't get to assign. You don't get to decide who goes to which school. So you're gonna have these problems. So that's called assignment bias. And that will create differences between your group that are going to affect, the dependent variable. It's going to affect the rate at which students get pregnant. And you have no control over that. So you're gonna have, problems with the experiment. It doesn't mean you shouldn't do it though, okay? You can still compare, okay? It still provides information, okay? So here's the thing. So with a differential, okay, now let's talk about a differential research design, okay? A differential research design is a type of a study where you create groups of individuals on specific individual differences like gender or age. So this is a different type of design, okay? This is another example of a non-equivalent group design. Okay, we're still talking about between subjects designs here. Okay, here's the thing. You can do what's called a differential research design, where in this design, you create the groups, but you create them based on gender or age, right? So you create, you have males, you have females, right? Maybe you have people who are heterosexual, homosexual, lesbian, gay, whatever you want to call them, right? And you can look for differences among these groups. That's called the differential research design. You're looking for differences among the groups, okay? So you create the groups based on differences that already exist. You don't really create the groups. You're more like basically defining them, okay? You're just defining them. The groups already exist, but you're defining them. But just for the sake of the lecture, say we're creating them. We're really defining them, okay? It's also called an ex post facto design because you look at differences after the fact, okay? So you have these different groups and you just check for differences between them after the fact. The groups exist, right? So you can compare, let's say, self-esteem, the self-esteem score of children from two-parent families and single-parent families. These groups, already exist. You're just defining them, right? There's children who come from two-parent families, and there's children from single-parent families. You can locate these children. You can give them a test of self-esteem, and you can see if there's any differences. That's different. That's a differential research design, also called an ex post facto design. Okay. Note, there's no treatment conditions, right? You didn't get to decide who was in a two-parent family or single-parent family. You didn't manipulate that. Okay. You have no control over the assignment of participants. You didn't get to decide who goes in a single-parent family or who goes in a two-parent family. These people already exist. So it's a non-experimental design. It's non-experimental. Okay. But it's called a differential research design because you're just comparing groups that already exist. So like I said, there's a lot of terminology here. Let's talk more about these non-equivalent group designs. So there's some similarities here between differential research and correlational research. This is just a kind of a side note over here, but there are some similarities between doing a correlational study and doing a differential research design. With a differential research design, you use one variable, like let's say attachment style, to create the groups, or maybe gender, or maybe sexual orientation. You use something like that to create the groups. With a correlational study, you measure two variables for each individual, okay? However, it says you produce different kinds of data for and you use different statistical analyses when you do a differential design and a correlational design, okay? Both differential and correlation designs are interpreted differently. So you have correlational designs, you have differential designs. They're different types of designs, right? Produce different kinds of data, different types of analyses, and you interpret the results differently. And here's a slide to tell you a little bit more about this. So here's the thing, with a differential group design, differential research design, that's the what's being depicted there at the top. You have the high self-esteem group and the low self-esteem group, right? So you have these different groups, let's say. And then you could measure their academic performance. You can check the academic performance of your high self-esteem group, and you can check your academic performance of your low self-esteem group. And you determine if there's any difference in the scores, any differences in the averages, let's say. When you do a correlational study, and that's the second set of data that you see there, you measure self-esteem of your participants, and then you measure academic performance in your participants. And then you do a correlation between self-esteem and academic performance. So it's different, okay? One gives you a correlation, the other one you're testing a difference. You're looking to see if there's a significant difference. But believe it or not, these two studies over here, even though there's different data, different statistical analyses, they're basically telling you the same thing. Let me explain why. If you find that there's a difference in academic performance between a high self-esteem group and a low self-esteem group, if you find that there's a difference between them, that also means that there's a correlation between self-esteem and academic performance. You can do it as a correlational study. You can do it as differential research design. Okay, different data, different statistical analysis. However, the two studies are telling you the same thing. It's like this. Let's say you find that there's a correlation, let's say, between age and, let's say, and self-esteem, let's say. Okay, you find that, let's say, younger people have higher self-esteem. Well, let's say, okay, you do a correlation between age and self-esteem. You're right, do a correlational study, and you find that there's a correlation between age and self-esteem. Okay, and that there's a positive correlation. That means the older participants are, no, there's a negative correlation, let's say. That means the older participants are, the lower their self-esteem. If you do the study a different way, and you have people who are older, people who are younger, and then you measure their self-esteem, you'll find that there's a difference between self-esteem. The self-esteem of the older people will be lower than the self-esteem of younger people. Okay, what I'm trying to explain here is that if there's a correlation between two variables, that means that if you do a differential research design, looking at that same thing, that you're going to find a difference. Or say another way, if you find a difference among two groups in, let's say, in their self-esteem, okay, between, let's say, if there's a difference in self-esteem between males and females, let's say, if there's difference in self-esteem, then if you do a correlation between sex and self-esteem, you will find that there's a significant correlation there. Okay, so what I'm saying is this is redundant. Okay, when you do a differential research design and you do a correlational study design, yes, they are different designs, but they tell you more or less the same thing. Okay, let's keep going. I think I've said too much about that already. Let's talk more about non-equivalent control group. Let's talk about what's called a non-equivalent control group design. This is a different kind of design. With a non-equivalent control group design, again, you use pre-existing groups, okay? But you have one group that serves as the treatment condition. The other one serves as the control condition. The individuals are not randomly assigned to the conditions. You have different groups. One serves as a treatment, one serves as a control group, okay? And you compare them, right? One example would be you compare students who have and who have not taken an ethics course. So there's a group of people who haven't taken the class ethics in college, let's say. And there's another group of people who has. Well, the ones who have not taken an ethics course might be, for instance, a bit less generous than those that have taken an ethics course. Just as an example, taking certain classes can change you, okay? If you've taken one class and another group of people has not taken the class, you might find that those groups of people are different. Let me give you another example so it's a little bit clear, okay? And I've actually read research about this. There are differences in how generous people are based on whether they are, let's say an economics major or a non-economics major. People who major in economics are, for the most part, less generous, is what the research finds, than those who don't major in economics. You can test these groups, right? You can test economics majors, non-economic majors, and then you could basically measure how generous they are in some way, okay? You'll find that the ones who've taken economics are less generous than those who have not. And why is that? If you think about that, right? People who take economics, who major in economics, what do they learn about? They learn about capitalism. They learn about self-interest. They learn about greed. They learn about different things, okay? That basically, they learn about competition and out-competing your opponent, things like that. And guess what? Because of that, they are actually less helpful. less generous than people who have not taken economics, who have not majored in economics. Think about our society. Think about our economics here in the US. We have capitalism. We have the stock market. We have, and then, what does this society produce? It produces a lot of inequality, right? If you're very capable and you start a business and your business is successful and you outcompete your opponents, then you become successful. The other people who are not so successful, they fail, they go bankrupt. A lot of competition here. Money talks, greed is good, that kind of stuff, right? That's what you learn in economics. You learn about self-interest, okay? And what that does is that it basically means there's going to be winners and there's going to be losers. And when people learn about this, they're more likely to view other people as people who are non-deserving, as losers, and things like that, and they're less likely to be generous with them. Then let's say if you take different courses, right? Let's say you're instead a psychology major and you learn about how people, let's say, can have problems and people and how people treat each other and how it creates difficulties for people. Let's say you take psychology instead. You're probably likely to be more generous in that case than, let's say, if you take economics, right? That's an example of a non-equivalent control group design. You have people who haven't taken a certain course, let's say, they're the control group, and people who have, they're the treatment group. It's an example of another type of design that is also non-experimental, but you still compare groups. Other examples here, there's also what's called a post-test only design. I told you guys, there's gonna be a lot of terminology. With a post-test only design, you're gonna compare a group that's given a treatment with one group that is not given a treatment, okay? The group that is not given a treatment serves as the control group. And there's some terminology here, or not terminology. What's this called? Some labeling here that you need to learn. Okay, so X stands for treatment, and O stands for observation/measurement. So if you see an X, that means they got the treatment. If you only see an O, that means that they were observed, they were measured. So you have XO and you have O there. So X. So this first group. So XO means that group, they received treatment, and then you observed and measured afterward, okay? And then you have the other group, they don't have an X, they only have an O, okay? So they didn't get the treatment, and then you measure, right, their responses afterward. That's the non-equivalent control group. So you're really comparing the scores of those that received treatment and those that did not receive treatment. That's a post-test only design. X stands for treatment, O stands for observation. If you use random assignment in this type of design, then you use an R rather than an X, okay? The R represents, pre-existing groups, okay? No R represents pre-existing groups, okay? If you use an R, that means you use random assignment. So you use an R instead of the X, right? No R means you have pre-existing groups, okay? Like this example here, the groups already exist. It's also called a static group comparison. Okay, more terminology. An example would be the teen pregnancy study that we mentioned earlier, where that I mentioned before. X means that in that group, right, they went through the teen pregnancy program, and then you checked the pregnancy rates sometime later. Another school, they didn't get the teen pregnancy program, and then you check their pregnancy rates later. Okay, that's a post-test only design. If you use an R, that means that you use random assignment. But in this case, this example with the teen pregnancy program, you did not. You can't use random assignment. So there is no R. Like I said, a lot of terminology. Pre-test, post-test, non-equivalent control group design. Okay, more terminology, a different kind of design here. Here you compare two non-equivalent groups. One group is measured twice, once before treatment and once after treatment. The other group is measured at the same time, but does not receive treatment. Okay, and here are the examples. Here's the terminology for that. So you have O, that's observation, measurement, right? And then you have treatment, that's the X, and then you have observation, measurement again. Okay, and another group, they have observation, measurement, and then no treatment, and then observation and measurement. That would be the non-equivalent group design, non-equivalent control group. Okay, so you're still comparing two groups, okay, but one got a treatment and one did not. Okay, that's called the pretest, post-test, non-equivalent control group design. Okay, that's kind of a mouthful there. Terminology, but it's really not, the terminology makes it sound complicated, but it's really not complicated. You measure a group before treatment, and then you give them treatment, then you measure after treatment. An example would be, let's say that you have people who are depressed, right? You measure their depression before treatment, then you have the therapy, the treatment, right? And then you measure the depression afterward. Hopefully it's gone down, that's the treatment group. And then you have another group of people who are also depressed. You measure them, they don't get a treatment, and then you measure them again. Okay, that's what you do. And you compare the different results there. More about the pre-test, post-test, non-equivalent control group design. The addition of that pre-test measure reduces assignment bias. So remember, you measure twice. You measure, like one group you measure before and after treatment. Another group you measure, you know, doesn't get a treatment, but you still measure twice. So you have a pre-test, okay? You measure things twice, okay? This pre-test reduces assignment bias. You can compare the observations before treatment to see if the groups are similar. So here's the thing, you can compare this. You can compare the depression scores, let's say, of the treatment group and the control group, you know, at the beginning of the experiment. And then one group goes through the treatment and the other one does not. And then you see if their scores are different afterward. So there is some assignment bias that is reduced, okay, because you have a pretest. But other variables are not measured or controlled. You don't eliminate assignment bias completely. You only reduce it. Okay, let's keep going. Pretest, post-test, non-equivalent control group design. More about this. So both groups are observed over the same time period. Okay, so you observe both groups over a period of time. So time-related factors like maturation are minimized. Okay, because you observe both groups over time, right? The time-related factors are going to be the same for both groups. They're both going through, you know, the you could say the study at the same time. Okay, so if there's anything that changes, they're both going to go through it. So you minimize time-related factors. If the participants are similar before treatment, right? Let's say there's the same level of depression before treatment, but there's a different level of depression after treatment. That means the treatment, let's say the therapy, probably had some effect because they were the same before therapy, right? They're the same before, all of them. And then one group went through therapy, another one did not, and they're different afterward. So you're more likely to say, okay, it must be due to the therapy. More about this pre-test, post-test, non-equivalent control group designs. If both groups show the same change after treatment, that means some other factor, something else other than the treatment is responsible. So if your groups, let's say, had the same level of depression before treatment, and then one went through treatment and one did not, and afterward they're still the same. Let's say the depression is different. Let's say they're both lower, but they're the same. That means it wasn't the treatment, because if it was the treatment, then the one that got it should have been lower, right? Those group people should have an average lower depression rate, average lower depression. Okay, so there must have been something else that affected the scores. They're the same before treatment, they're the same after treatment. One got the treatment, one did not. So there must be something else going on. The pre-test, post-test, non-equivalent control group design also attempts to limit threats to internal validity. Okay, there is some evidence of cause and effect, right? It does try to limit some problems, some threats to internal validity, right? So it's actually called it's called quasi-experimental. It is quasi-experimental. Remember, quasi-experimental means it's kind of like an experiment. Okay, because you have a pre-test, post-test, right? So you can check for some problems early on, right? You can reduce assignment bias. more about the pretest, post-test, non-equivalent control group design. There are still threats from differential effects. Okay, there's still some problems there. The non-equivalent control groups can be run in separate locations, right? And that can be affected by time-related effects. If they're in separate locations, the groups might behave differently because of that. Or there could be an outside event that can affect the groups differently, a type of history effect. There could be something that happens to one group, but not the other. Let's say an example might be one school having a winning football season and the other one doing poorly. So let's say you're testing the self-esteem of in two different schools, right? Let's say, right? Two different schools, you check the self-esteem before treatment, and then one of the schools, they have the treatment, and then the other one does not. Well, what if something else happens to one of the schools? What if one of the schools is having a good year? Their football team is really doing well that year. And because of that, they feel really good about themselves, right? That's a confound. That confound might explain differences. One group is going through something that the other group did not. That's a potential confound. Let's talk about pre-post designs. Pre-post designs are studies in which there's a series of observations that are made over time. Okay, pre-post designs. So there's one group of participants that is observed and measured, right, before and after treatment. You compare the observations before and after treatment to see if there's an effect. Pre-post design, okay? There's one group of people, you measure them before, you measure them afterward, right? There's no control group, so it's considered, and it could be non-experimental or quasi-experimental. Let's get a little bit further so I can give you an example of this, okay? Now, with pre and post designs, right, there are some potential problems. If you measure before, you measure after, right, and there's no control group, you can have time-related factors, you can have history, right, be a problem, right, where, or, maturation, right, where basically things happen as time goes by that affects participants. That might be a type of history effect, or that might be maturation. Participants change on their own over time. There could be instrument issues that happen as the research progresses. There's testing effects, right? You measure once, you measure twice, right? You could have instrument issues where, they just score differently because the instruments aren't working properly, or the fact that they've tested more than once means that they've seen it before. That could create differences. Statistical regression, again, that's hard to explain, but that's where you get extreme scores and then they go back to average over time. It's impossible to counterbalance the order of treatments to minimize time-related factors. You can't really counterbalance because, well, you don't really have a control group, okay? Before treatment, the pretest always comes before, okay, so the before treatment observation, when you measure before treatment, that always happens before the measurement of the after treatment observation, okay, the post-test. So you have a pre and post-test. The pre-test always comes before the post-test. That's just the way it is. You have no way to counterbalance that. You can't have the post-test before the pre-test. It just doesn't work that way, okay? It's always the same order. Here's one example. You can have what's called a one group pre-post-test design, which each individual in a group is measured once before treatment and once after treatment. So remember, O stands for observation and measurement. Then you have treatment, maybe therapy, right? And then you have afterward observation and measurement again. So you measure depression before therapy, then you have therapy, and then you measure depression afterward. Another example would be assess attitudes toward a candidate before and after they view a commercial. So somebody's running for office, right? And you ask them to what extent they're likely to vote for that person. And then you play a commercial for them about that candidate. And then ask them afterward, now how likely are you to vote for this person? Okay, happens a lot, right? You see that kind of stuff on TV. This is considered non-experimental. There's no control of threats to internal validity, right? No cause and effect inclusion here, right? You're not controlling anything, all right? There's no real cause and effect here. You're just measuring before and after the treatment. before, their attitude towards something or someone before and after the commercial. Okay, let's stop there because we're just about out of time.